we are going to start the chapter 4, which is a heavy-duty chapter. And from here, we are going to learn about how to create tables in a database and how to create a SQL language, which is like a programming language for us to interact with this database. So before we talk about like how to do that Microsoft Access, let's learn about the fundamentals of a relational database. So to start, right, what is a database? So the database is just the collection of relevant information for accountants and managers to make relevant decisions. So a database is just like where we save all this information, right? So then what is a relational database? So now what does this adjective relational mean in this context? So here, the relational database just is a type of database that where the tables within the database are interlinked with each other. And we learned from the previous chapter that there is a feature that establishes the linkage between classes or tables. And what is the name of that feature? In the last chapter, right, we said that there is a primary key and there's a foreign key. So which key acts like a bridge between two tables, or which key establishes the linkage between two tables? Let's refresh our mind. The primary key is the attribute that uniquely identifies each incident, right, or each instance. Now, the foreign key is the attribute that actually establishes the link. So I think you are confused because foreign key is also a primary key in the original table, right? But when we say a feature is establishing the link, that is a foreign key. Okay, so the primary key is when the feature is still sitting in its original table, but when it's acting like a bridge, that feature goes to another table that it's linking to be a foreign key. So later we're going to review that. But this is what we discussed last time, right? We say that we have primary keys and foreign keys link different tables. And therefore, the tables will be related to each other, right, via these linkages or via these foreign keys. So because of this interlinkage, we call this kind of data structure or this type of database as a relational database. So in the textbook also describes other formats of the database. For example, we have hierarchical database, and then graph database. So the reason that we are learning about relational database is that this type of database is the most commonly utilized database so far in the business world. So when you act as a, let's say, in-house accountant or public accountant or auditor, you are going to deal with relational database in your daily work. So you have to learn how to retrieve data from the company's relational database and also how to audit information from those databases. So that's why in this AIS class, we are putting a relational database as the fundamental skill that we have for as an AIS student to learn about AIS. So fundamentals of relational database. So these are very similar, or these are the same as what we learned in the UML class diagram. So first, in relational databases, we also have the concepts of entities and attributes. So entities are the same as classes that we discussed earlier, right? So we say entities or classes, they are collections of things that we want to collect information about, right? For example, cash, salesperson, customers, and so forth. And attributes are basically like characteristics of that class. So we learned a lot about that in the UML class diagram, and it's the same here. Now, this is an example of how a table will look like in a relational database. So in a relational database, we use a table to represent a class. For example, if we have a class called inventory, then we can create a table also named inventory. So in a relational database implemented in the Microsoft Access, the table name will be on the top section, which later you will see, but the name of the table will just be the entity name or the class name. And then we have attributes, right? So the attributes will be represented using these columns. So the column name will just be the attribute name. So for example, in this inventory class or inventory entity, we have attribute of its ID, which is the primary key here, and the inventory's name. So here, this is the example of different drinks or beverages. So the names are all names of that specific beverage. And then beverage type, caffeinated or not, flavored or not. So these are all attributes. And we also say that in a class, we have instances, right? So an instance is just an individual object. For example, we have a particular type of beverage named French vanilla, something like that. So this is how a table looks like in a relational database. Now we have some illustration of like how, now let's look at how different tables can be interlinked with each other via foreign keys. So now we have three tables illustrated here. We have a customer table, sales table, and product table. So customer table is just a table that represent the customer class. And here we have attributes of customer ID, the customer's name, customer's address. Now the first question is, what is the primary key for the customer table? Yes, that's easy catch, right? Okay, so now I want someone to tell me what are the criteria that we talk about that can make an attribute a primary key. Yeah, it won't change. Yeah, thank you so much. I'll provide a very good answer, right? So we said that the primary keys have to be unique and they don't change. They cannot be null, right? And what do we say about the best practice of generating a primary key? What do organizations usually, for example, at Rutgers, right? We have RUID, which is a sequential number that the organization can manage to make sure that this attribute fits the criteria of being a primary key, right? So that's why in a lot of the tables, if you see these kind of serial numbers with the name ID, yeah, then that is a primary key. And usually a primary key appears as the first column of a table. And later in our practice, you will see that in Microsoft Access, the first attribute or the first column you create is a primary key by default. Now, so then we can quickly circle the other primary keys in other tables, right? So for example, in sales table, the primary key is the invoice number because it shows this is an index for each transaction, right, or each invoice. Let's look at what other attributes are here. So in the sales table, it also tells us which customer made the purchase, on which date, and what did they purchase. And then on the product table, right, we have the product number as the primary key, and also the name of the product as one attribute, and the price as one attribute. Now, let's look at how these tables are linked, right? So then we have to identify foreign keys. The first question is, are there any foreign keys in the customer table? So if that's the customer's name, we say that foreign key acts as a bridge, right, to other tables. Then what is the name linking to? So here we say that customer ID is already a primary key here. Okay. So when we say a foreign key, it has to be like in another table. The foreign key, usually it's not the same primary key, right? On the sales table, okay, that is correct. Okay, so on the sales table, so that's correct. So let me go back to my original question. The original question is, are there any foreign keys in the customer table? There's no, okay? There's no foreign key in the customer table. And earlier, Adrian, you showed me the assignments, right? So you did that last question in your assignment that asked you what should be the foreign key, right? here we are talking about this is clearly a one-to-many relationship where the foreign key is posted on the many side, which is the sales side, right? So here on the one side, there is no foreign key, right? So in those cases, you choose 0 because there is no foreign key, right? And now, the customer ID, which is the primary key for customer table, is a foreign key in sales table that links these two tables together. So are there other foreign keys in the sales table? Yeah, product number in the product table. Okay. So now the product number is a primary key in the product table, but it's a foreign key in the sales table, right? So now we have these two linkages, right? So now all the three tables are interlinked with each other. So this is the concept of a relational database, right? So in this database, all our tables are linked with each other via these bridges, via these foreign keys, right? That's why it's called a relational database. And also by having these linkages, so a reason why we are using this relational database is that this is efficient. So here, the reason why we're using a relational database is that we do not have to create a gigantic table that stores all these information. Instead, we can put information in different tables so that when we want to combine them, we can just do it on the fly. So, for example, let's say on the sales table, right, we look at this invoice ID and we have the customer ID. So, which means we know if we look up this 0 to 602 1238, then that corresponds to this customer Mark Wagstaff, right? So, and now we know where this customer lives. So then you can store much less information because let's say you keep a sales table, and when needed, you look up to this customer table to know details of this customer. And then you have a product number in this entry, right? So you say, okay, what is this product 1233? Let's look up on this product table. Okay, 1233 is iPhone, and this is the price. So having this interlinked table structure is an efficient way for us to structure information and to manage the information. For example, let's say, well, we have a new customer, right? We just need to add one entry on the customer table. So we just have one table to revise and one entry to add. But if we do not have this customer table, but rather store all these other attributes in this gigantic sales table, we have to revise all related information that's made by this customer, right? So it's from an efficiency point of view, relational database is very, very agile in this sense. Okay, so now moving on. So earlier, Jenna, Kush, and Yen talk about the primary key properties, right? So one of the properties is that the primary key cannot be null. So in a relational database, we call this entity integrity rule, right? Basically, it just says the same. The primary key cannot be null. And in relational database, we also have a rule for foreign key. So now, okay, foreign key, unlike the primary key, foreign key can actually be foreign key can actually be null. But the only bottom line is that if there is a value for the foreign key, that value has to be existing in that corresponding table. For example, let's say we have a customer ID number here, which is a foreign key, right? This number has to exist in its corresponding source table in the customer table. In other words, you cannot make up any numbers for any foreign key values. The number, the value here has to exist in the source table. And similarly, if you look at this 1334, right, this product number has to exist in the product table. So that's called referential integrity rule, right? So if you want to trace back to the source table, it has to be there. So that's what referential integrity rule says. Now, there are other rules too. Okay, so besides the primary key and the foreign key restrictions, we also require that different attributes have unique names. For example, here we have 5 attributes, right? And each attribute or each column has a unique name, which is just to say, well, you cannot have 2 columns that have the same name. Otherwise, we don't know which column are you referring to, right? So that's a very basic requirement. The next requirement says each column needs to include values of the same type. So what does that mean? So that is basically saying, let's say under the name section, right? We require the names to be in textual format, meaning words, okay? Words or sentences or phrases. It cannot be numbers. And let's say ID, right? Inventory ID. If you decide to use sequential numbers as an ID, then only the numbers can be ID. It cannot be textual information. And in some cases, there are some binary or Boolean variables. For example, whether or not this beverage is caffeinated. So it can only be yes or no. You cannot put maybe or others, right? So this is a restriction on the data type. For a column, it has to follow the same data type. Next, it says each row of a column must be single valued. This is what we discussed last time about why we cannot place a foreign key on the one side of this one-to-many relationship, right? For example, we said we cannot place the auto ID as a foreign key in the person table because a person may own multiple cars at the same time. If that's the case, then you would have a cell on this table that have multiple values. For example, Abby owns 3 cars, car number 1, car number 2, car number 3. This is not supported in a relational database. In this database, each cell or each row and column, it has to be single value. And of course, for your attributes, they have to describe the same, they have to be meaningful enough to describe a characteristic. Let's look at if we were to implement a relational database, what are the steps, okay? So here we are going to see why UML class diagrams can be a blueprint to create these relational database. So I have 5 steps here, but let's just understand it by going through the steps from the slides here. So the first step says we have to map classes in UML diagram into tables. So that is to say, for each class, we need to map that class to one table. So now, how many classes are on this UML diagram? 4. Yeah, exactly. So then if we say we have to use one table to represent one class, then how many tables are we going to have? So if we use one table to represent one class, and if we have 4 classes, how many tables are we going to have? Yeah, exactly 4. Sometimes I ask very simple questions, right? So don't be surprised if the answer is too intuitive. That's correct. You have 4 tables. And like, okay, for person, this class will have a table for person, right? Auto, and then we have an auto table, and so on and so forth. So that's step number 1, right? We just need to map class to table, one class, one table. So number of classes equal to number of tables. That's the first step. Now, second step is that like in a relational database, each table will have a primary key, right? So now the next table step is that, okay, now we have these tables. What are their primary keys? We have to identify them or generate them, right? So now I'm just giving these primary key indicators because, for example, for person, then the primary key is just person ID, right? Auto, then that's just auto ID. Dealer ID. Here, states, this is a special one. We can use the abbreviation of state as the primary key, right? For example, NJ is just NJ. New York is just NY, right? So here in this case, you don't have to create a serial number to be a primary key. So that's just the second step. Now, the third step, which is like we have to establish linkages between the tables, right? So because that's what we call relational database. Now, to refresh our mind, right? So first of all, how many associations are on this UML diagram? Between person and auto, what type of relationship is this? Gina said one to many, correct? So then we say, where should we post the foreign key? So between person and auto, got the many side, right? Okay, now between, and then another question, what should be the name of the foreign key posted on auto if we're linking to the person table? Person ID, that's correct. Because we said that's the property of foreign key, right? So the foreign key is, if it's linking to the person, then that foreign key has to be the primary key of the person table. But on the auto table, it's the foreign key. Okay. Now, similarly, between auto and state, where should we post the foreign key? Yeah, hold on. Auto and state. What's the foreign key name? State. Yeah, correct. Yeah, so that should be the state abbreviation, right? Now, between dealer and auto, what kind of relationship is this? Many to many, and we say, what should we do in this case? What should we do when we have a many to many relationship? Right, create a linking table, right? And last time you did that exercise on stage. If there's a many to many, you don't post it to both sides. There's no way that you can do it. You have to create a linking table, right? To implement it. So now, so that's actually combining our. So here, let me just show the step where we can directly post the foreign keys, right? So we said that on the auto table, right, we are going to have two foreign keys. The first one is the person ID that links to the person table. And the second one is the state abbreviation that links to the state table, right? And also we have this many to many relationship. So you can create a linking class and that maps to an additional table. So eventually we're going to have 5 tables in this case, right? Because we have an additional linking table here. And then this is, we can directly do this in Microsoft Access. So pretty much this summarizes like what are the general steps, right? So basically we have classes, we map it to tables, identify the primary keys in the tables, and then link the tables. And if there is a many-to-many relationship, we create a linking table or linking class, and then connect each tables using these foreign keys. So that's like these the steps at a high level. Okay, so now so we have this thick handouts, right? Irina was giving everyone a copy. So this handout is it has 6 pages, and mostly these are from the textbook. I print them out because this is very it's convenient for you to have something on paper to see when you are doing this exercise on Microsoft Access. So all the copies are on the first row. I can give this to you. First page. The first page is just the description of the case, okay? So in the textbook, it's already there. And I think in your preview, you already read this case, right? So there's no need for you to, for us to separate time for you to read that case. So let's say that you already read up that case, and now we are able to plot the UML class diagram, right? So this is what's given in the textbook. We don't have to do it ourselves. Let's just say, well, after some hard work, right, now we have this UML class diagram. I want to call your attention on how this UML class diagram is organized. So in the last class, at the end, we talk about the best practices of creating UML class diagram, right? But one thing we didn't mention is that we can actually cluster different classes in a way that one group can represent resources, the second group can represent events, and lastly, we can have some classes that represent agents. So what do we mean by resource, events, and agents? So you can pretty much regard assets of a firm as resource, right? Because resource or assets are just anything that can generate value to the firm, right? So here, the inventory is an asset, cash it's a current asset. So we cluster them in the resource side. And by the way, this way of organizing, like organizing classes into resource, events, and agents, this is called REA modeling. Okay, so this is just a way to represent information. So in general, we put R first and then E in the middle and agents to your right-hand side. And then agents, these are very easy to understand. These are just person, right? So any class that represent person, like salesperson, customer, cashier, right? So these will be agents. And events. So events are just like, for example, transactions, things that happen, right? So sales transaction is an event because this is a transaction that happens. Cash receipt is also an event, right? Because it's you receive cash from the customer. So this is a general way that we organize information. And we also have slides about how to interpret these multiplicities, right? And we use that as practice in the previous chapter, so we won't go through that. We get to the core part of this class, which is to use Microsoft Access to create a relational database. So we mentioned that each class will map to a table, right? So now if we look at this UML class diagram, how many tables do you expect us to create? 7, right? Do you guys agree? We should create 7 tables. We, on your handouts, on page 3, so if you prefer to have an e-copy of the handouts, it's actually available in the class module. So I put it here. So on page number 3, right? So this is another way to represent tables. Earlier, we usually represent tables by using this rectangle, right, with a name on top and features as a list below. This is another way to represent tables in textual format. So the way that it's structured is that you have a table name, which is the class name, and then the attributes or the columns for that table will be enclosed within a square bracket. And these attributes will be separated by commas. Okay, for example, in the customer table, we have customer name as an attribute. The next attribute is the first name, and then next is last name, so on and so forth. So here we use primary key or PK in parentheses to indicate whether an attribute is a primary key. And similarly, we use FK or foreign key in parentheses to represent if an attribute is a foreign key, right? So now we can tell, oh, okay, in the sales table, we have 2 foreign keys, right? So this is another way to represent these tables. And if you count, we have exactly 7 tables. So we're going to use this as a guide to implement the tables. So now let's do the real practice, right? Okay, so first of all, we have to pull out our Microsoft Access. Now to do that, I usually just do the search in your search bar. You just type Access and then it should pop up. So on this computer, on the podium, it's having the 2016 version. You may have higher or lower version. It doesn't matter. Access hasn't updated that much. So you can just click it. So because we're going to create a brand new database, right? So we're going to select this blank desktop database. And by the way, from here on, this Microsoft Access, this tutorial will be like very, very detail oriented. Like this is the button we click. This is what we type. Right. So if you cannot follow me, please just make me slow down because for this chapter's assignment, you are going to use Microsoft Access to create your database, to create your SQL programming language, and you're going to use it for your midterm exam, and you're going to use it for your project in the group project, right? So make sure that you feel comfortable with using this software. It's not hard at all. It just comes with experience. Once you go through it, you will learn how to use it, right? So just make sure that you ask if you don't follow me, or make sure you understand. So the first thing that we notice is that you can choose a different place to save this database. So if you are using your own computer, right, you can save it to your class folder. If you are using your laptop, just make sure that you save it somewhere handy. For example, desktop, so that later you can email yourself the copy. Make sure you have a copy of this file, because next time we're gonna continue working on this. So I'm gonna save it on the desktop. So here, let's give it a name, because the case study is called Steve's styling sunglasses, right? So let's just say SSS. You can name it in other ways too. I'm just making it easy for myself. And you can say AIS, and this is section number 3, right? So we can do OK. And then you click Create. So now we are in this user interface. Okay, so once you are here, let's first take a look at what are the options here, or what are the functions available in Microsoft Access. So first of all, we are by default on this tab called Fields. So this is a tab that allows us to edit the table, especially from this view function. Later, we will show you how to do that. And you also have other options like using different formats of which we will also learn about. The Home tab contains some standard functions. For example, you can choose the font, right? So it's similar to Word. And then there's a refresh button. So if you insert any data and if you hit refresh, the data should be synced up to date. Now the tab Create, this is where you create a new table, or later on when we create SQL queries. And this tab External Data can allow us to import data saved on external sources. For example, you have Excel file and you want to import it to Access, then that's how you do it. Or you have data in this database and then you want to export to other formats, for example, CSV files or other files. This is the place to do it. And then database tools, a function that we're going to use is called the relationships. This is where we put all these tables together and draw a line between them to create their association. And the last table file, I think this is where you insert or delete rows, or just delete a table, something like that. And so the main working area is this blank space here, right? And to your left, you have a panel that shows you how many tables do you have in this database. Because we're just starting, right? So we only have one table by default named Table 1. So that's pretty much how this tool looks like. And now, so now we created a database, right? You named it as SSS AIS section 3. So our database is ready. Now the next step is to create tables, right? Because earlier we said that our steps are, we use the UML diagram as a guide, and then identify how many tables to create. And we said that we have to create 7 tables, and we have a list of tables on this page 3 of handout. So now our task is going to create 7 tables, each table representing a class, okay? So for the rest of the 30 minutes, I think we will only have time to create one table because we need to learn about some details when we create each table. Okay. So now let's create our first table. Let's just follow the sequence of the list of tables on page 3. Okay, so now the first table we're going to create is the customer table. Okay, so first thing is that we want to change the name of this table 1, right? And we want to add columns. So to do that, we go to the view. So first, make sure that you are in the fields tab. And then you go to view this drop-down list and select this design view. Okay, so now you have the option to change the table name. So you can also open the textbook on your side because it has very similar instruction. So if you missed some part, you can also look at that. The textbook as the guide. But in general, the steps are very similar. So here we can name it as customer and click OK. And now we will be directed to the design tab. Okay, let me know if you want me to repeat because sometimes the screen is a little bit small, so you may want me to repeat. So if you click that, right, and then it will be directed to this page. So now let me walk you through different sections. So first, we see this highlighted section, right? It's called field name. So this is where we create these columns in this table. And here, by default, the first field or the first column will be a primary key. How do I know that? This is because there is a key icon placed next to the first column. And another way to tell is that the primary key on this ribbon here, this is highlighted. So by default, the first attribute you create will be the primary key field. This one is called data type. So in this data type, remember earlier we said that in a relational database in this table, right, each column should have the same type of data. And this is where you can define what type of data I want. Should it be number? Should it be date? Should it be a zip code format? Should it be currency? Or should it be text? This is where you can select the type of data. And then this field is called description. So this is just some voluntary information you want to include. For example, let's say you have a field called, let's say, caffeinated. So that name is not that informative, right? So you can put a description. This column shows whether or not this beverage is caffeinated. So you can put some description to that field, but this is an optional field. So these are the most basic property. And then down here, you have a whole section about more detailed properties of a column. And later we're going through some of them in detail. So now let's try to create our first column, which is the primary key for the customer table. And by the way, if you see any feature name with PK or FK in parentheses, you do not have to include that in the name. Okay, so for example, our first column is customer number. You just put customer number. You don't have to put PK. So I am typing in customer and then underscore number. Here, you may ask, okay, should we include the underscore? Can we use a space instead? It is okay. So the reason I am using an underscore is that it just makes it more convenient later on when we learn the SQL programming language. Because if you do a space in between, you have to enclose that customer space number in a square bracket whenever you refer to this name. It's just not convenient. So I prefer either do not have any space at all, like for example, just customer number, right? You can capitalize the word so that it's easier to read. Or if you want, you can do a space, but replace the space with the underscore so that there's no space whatsoever. It's just more convenient later on. So that's like a a good practice for naming these attributes. Okay, so that's the name of our primary key, right? And now we should choose a data type for the primary key. So by default, for any primary key in Microsoft Access, the data type is called auto number. Okay, so this is a weird number, weird name. So what does auto number mean? So this is saying that if you do not have like a predefined primary key, let's say RUID, if you don't have that, then the system can automatically generate some random numbers as the primary key for that attribute. So here, if you don't have let's say if you don't have RUID, that kind of thing, then you can keep auto number. But let's say we have some predefined customer number. So then we just need to choose just a number as the data type. So to change that, you just click the drop-down list, and then you can select number. Okay. But before that, let's take a look at other data types available. So the first data type is called short text. So this is often used when we are having like the names, right? Because the names are in words or in texts, or let's say addresses, right? So that's also short text. And the next type we have is long text. So long text by its name, it's like really, really long phrases or words, usually in paragraphs. So in general, short text is very, very enough for our business usage. So if it's a text, just choose short text. There's no need to use long text. And number is just like any number, right? Numeric values. And date or date and time is just like month, year, date, that kind of data. And currency, this will require us to include numbers with dollar signs or other currency signs. We discussed auto number. And the next one is yes or no. This is a binary data type, right? So for example, whether or not the string is caffeinated. So it's either yes or no. There's no maybe. There's no other options. OLE object, you don't have to understand this. This is something like converting images to pixels, that kind of data type. So usually this is not commonly used, at least in this course, right? So it's okay not to use it. And then hyperlink, this is when you need to include like URLs, like website link. Attachment, it's just like any files. Calculated, I think this is some formulas. So here, let's just use number as a data type. Okay. So once we are here, usually it's okay to just move on, but as a learning process, right, we also want to look at other properties here. So now let's look at this properties under the general section. So here there are some important properties. So the first one is called the input mask. But here I will show you in another example when we do the zip code. But input mask is basically a template of how you want the value to look like. For example, let's say when we are talking about social security number, the format of the SSN is usually like fixed, right? You have 3 digits and then 2 digits and then 4 digits. So this one basically requires the user to provide that kind of format data to reduce the errors. For example, someone may mistype, so they have 4 digits, right? So if we require, okay, you have to input 3 and 2 and 4, then you reduce the mistakes from the user side. So that's about input mask, and we will learn about it later. Default value just says if there's no value assigned to that particular instance, then by default it has to be something. So depending on your use case, sometimes you may or may not have a default value. One example of the default value can be people's age, right? So for example, the default value should be something greater than 0, right? Because someone's age cannot be negative. So the default value is just something that if there's nothing there, there has to be some value, right? And that value has to make sense. So default value is also an important feature. Next one, validation rule. So validation rule is a very specific requirement on how the data look like. So the validation rule, to some extent, is very similar to the input mask. The difference is that the validation rule allows you to be more flexible in what you require. So in the textbook gives that example of, let's say we require customer number to be 6 digits, right? And then you can impose that rule. Here, you may feel like a little bit like stressed that, okay, how do I write that code to indicate that it has to include 6 digits? So let's first type that code here, and later I will explain to you that you don't have to remember this, okay? So let's say we require the customer number to have at least 7 numbers, right? Let's say, then we do this like, and then 7 pound signs in quotation mark, 1, 2, 3, 4, 5, 6, 7. So, so you just need to type like in capitalized L, and then space the 7 pound signs, or you can do 5 pound signs, whatever you want to do, and enclosed in quotation mark. So this is telling Microsoft Access that here we want something with 6 digits. Now you may ask, okay, I don't know how to do programming. How do I know what to put there, right? It's okay because we have Mr. Google to help us, right? So let's say, in any case, let's say, okay, I have an email field, and I want to make sure that the user is inputting the @ sign, and then .com or .edu, okay? And then if that's the case, what should I do, right? Don't worry, just ask Google, okay? So you guys are very good at searching online, so I don't have to teach you. I searched something like include out this @ in validation rule access, and immediately I was directed to something written by Microsoft. And then I have this answer here. This is a way to do that. And for example, if you want to make sure the values entered has to be greater than or equal to 0, let's say someone's age, right? Like a newborn baby can have age 0, but you can never go to negative, right? So this is a validation rule. So you can just put greater than or equal to 0. So there are some like formatting, or for example, if you don't know how to do certain things, like making sure that the text contains @ sign, you can always come to internet, right, to ask for help. The reason I say this is that now we have a lot of programming languages, like we have Python, we have SQL, we have R, we have Stata, you name it, right? It's just impossible for you to remember all these things. And we are in 2022, right? It doesn't make sense for you to just memorize things. So you have to learn how to utilize these resources and learn how to find information, right? So that is why in the midterm exam, I don't require you to remember these rules. You can do open book, you can search online to do certain things. That's totally okay, because that's what you are going to do in your work, right? You're going to work with your colleagues. You're going to have internet by your side. So don't worry if you don't know how to do things. Just search, right? That's how you learn programming, pretty much. Okay, so this is just something that, as I said, right? Some language that the Microsoft Access can understand that says, well, we need something that has 6 digits in this field. So that's about validation rule. And same thing applies to later when we learn about the SQL programming. there is a large resource center that teaches SQL. So if you type SQL, I think there is a very good resource SQL tutorial. Yeah, but yeah, I'll send you the link if I find that. But that's like a database of all these commands that you can use. I think this is a good one. Yeah, so we'll get to that when we start. When we get to next week. Okay, so don't worry about like this being the first time you do this kind of programming language. You can always search and ask for help. What is a validation text? The validation text is basically an explanation or description of the validation rule in plain English, right? For example, we say let's say this is some language that Access will understand. Now let's describe this rule in plain English. For example, we can say customer number has to be 7 digits, right? Okay. So the validation text will also be acting as like an error prompt message if any user inputs the wrong type of data. For example, next week when we learn how to insert value to this table, we can play around with what we insert, right? For example, if we insert a customer number with only 6 digits, not 7 digits, then we'll get an error message saying that the customer number has to be 7 digits. So this is widely applied. This kind of validation rule is widely applied in our daily life. So I think a lot of websites or your accounts require you to create a password, right? And when you create a password, they have some rules like, okay, your password has to be 8 to 20 digits. Your password has to include capitalized words and lowercase and numbers. So if you don't meet one of the criteria, you will get an error message saying, oops, you don't have enough digits. Okay, you didn't include uppercase, right? So it's the same thing. So you can't regard it as some prompt that if anyone didn't input the right information, then that's the error message they're going to get. Okay, now the next field is called the required. So this one here, it is yes. So required just means whether or not we require the value to be non-null or not. So in this case, because this is a primary key, right? So we have to have value for this field or this column. So this is always required for this primary key. So in general, right? So in this property, the important ones for us would be the input mask, which we will use in a minute, and then default value, validation rule, validation text, and this required or not. So that's our first column. Okay. So here we are taking some time because we are getting ourselves familiar with these features. But later, when you create other tables, you do not have to impose validation rule. Okay. So just for the first customer table. For other tables, it's okay to leave it as default. Now let's learn how to use the input mask. So we can. So now I want you to, before we do that, I want you to go through the attributes list, like first name, last name, and create these different field names. And you can keep the data type as short text because the names and other things will be just text type. Okay, so I will do it here as well. So for example, our second attribute will be customer first name. And by default, the data type will be short text and you can keep it. So you just need to go through the rest of the columns. Okay, I created all these columns. So you can just keep the default data type as short text. Okay, now if you finish creating these columns, let's go to the column of the zip, customer zip, because here we can learn how to apply this input mask. So if you already have this zip, okay, so you can click zip, and then you will have the properties of zip like below, okay. So then let's find the property called input mask, which is the third property here. So you can click this input mask, and then immediately there will be with 3 dots here. So you can click it. So you will be asked to save the table first. So you just click yes. And now you will have a list of these input masks to choose from. So again, input mask is just like a template of how your data will look like, right? For example, phone number. Here in the United States, right? This is how the phone number will be structured. You have area code, and then you have 3 digits followed by another 4 digits. So this means if you choose this as the input mask, you are restricting the user to input something like this. You cannot have more digits than that or less digits than that, right? Similarly, this is a template for social security number. This is a template for zip code. So here we can choose the template or input mask for zip code. And this will require that any user, when they input information to the zip code, then it has to be the 5-digit zip code followed by that area code. So it will be 5 digits and then hyphenation 4 digits. So it has to follow this format. And there are other templates to choose from, like long time, short date, short time, right? So you can apply that if you feel, well, I want this format to be like that, right? So let's choose the zip code and then just do next and then finish. Then now you will see that in this input mask section, it's automatically popping up this requirement, right? So basically this says it has to be 5 digits followed by 4 digits with a hyphen in between. So to some extent, the input mask is very similar to the validation rule. It's just that the input masks are templates that you can directly use for fields like phone number, addresses, phone number, SSN, zip code. For other type of restriction, you have to use the validation rule. Okay. So that's how you do apply the input mask. So you can save this table here so that you don't lose it. And now we can continue creating other tables. To create another table, right? So now we have the customer table. Let's see, next table is the salesperson. So to create a new table, we go to this create sign, create tab, and then select this table. So now you will have you have a fresh start, right? That's where we began. So now you have this table 1. So again, you go to this view, design view, and then you start all this process again. So we have salesperson. So you just follow the list of attributes right on this table on page 3. So from here on, it's okay to leave all these default settings. You just have to make sure you choose the correct data type. With one exception, that if you are creating attribute of SSN or zip code, you can apply the input mask in the property section. But other than that, you can use all the default settings. So when you create a table, you can use the screenshot on page 4 and 5 as your guide. For example, let's say in the sales table on page 4 at the bottom, you can see that, for example, you can choose date and time as a data type for the field sales date and currency for the amount, right? So you can first do it by yourself and then look at this as your reference. So you can continue creating your table and then make sure you save it, right? Because next time you guys come back, we're gonna spend time here to finish creating the table. So don't worry if you cannot finish here, and you don't have to do it at home. Right? You just have to come next time to pick up your work, but just make sure you save it, right? For example, let's say in the customer table, right? So for the zip code, or let's say SSN, should it be number as a data type? So the reason that we choose short text is that we have a hyphen in between, so that's not a pure number. And same for SSN, because we have hyphens between the numbers, so we still keep short text as the data type. Unless it's like purely just numeric, you say number. Yeah, you don't have to type F key. Yeah, so for now, you just need to type in the name. Because for foreign key and these connections, we're gonna do it separately on this relationship function. So for now, you don't have to worry about that. Yeah, you just need to make sure the primary key is indicated, and that's it. Indicated in a way that the first column you create is by default the primary key, but you don't have to put in parentheses PK. Oh yeah, so choose if you want to make sure you save to the right folder, right? Go to the File tab, and then there is a Save As. So this is where you can choose, for example, like Save Database As. Then you save the this Access database. You want to come there. Oh yeah, so you have to just choose that yes, and then you'll be able to choose where to save it. So I will put it on. Yeah. So if you finish that, you are free to go, and I will see you next week.